All right, so here's the example that involves partial fraction and the negative indices. So for example, here is x square x minus 8 over x square minus x minus 2 can be written as um, a over x plus 1 plus b over x minus 2. Now, when you factor this denominator, you clearly see that, okay, it's x minus 8 and x plus 1 times x minus 2. If you factor this part, and is a over x plus 1 plus b over x minus 2. What you do is you cross multiply. As a result, you get x minus 8 equals to a times x minus 2 plus b times x plus 1. Now, you input x is 2. So if I plug x is 2 here, I get 2 minus 8 equals to a times 0 plus b times, let's say, 3. So I get negative 6 equals to 3b. So that gives me b is negative 2. And similarly, if I plug x as negative 1, I get negative 1 is that in the both the sides in this expression. So I get negative 9 equals to a times negative 3 plus b times 0. So that results in a being equals to 3. So actually, the value of a here is 3 and value of b is negative 2. So after this, we get to the main expansion part. Now, hence right expansion, not the word Wednesday, hence, it means that you got to use this. If you use some other method, you won't get any points. So if I have got, let's say, x minus 8 over x squared minus x minus 2 up to x cubed term, I'm going to use this expression actually. So since my expression x minus 8 over x squared minus x minus 2 can be written as 3 over x plus 1 plus minus 2 over x minus 2. I'm just going to rewrite this as 3 times 1 plus x to the power minus 1 and minus 2 times negative 2 plus x to the power minus 1. It's the same thing I just written in the negative indices form. So what we do is we're going to apply the formula straight away for the first expansion. So I'm just going to expand this up till the cube term because they want up till cube. So 1 plus n is negative 1, so negative 1x plus negative 1, negative 1 minus 1 is negative 2, x square, and plus negative 1, and here divide by 2 factorial, negative 1, negative 2, negative 3 over 3 factorial, x cubed. And just remember the expansion of 1 plus x to the power n is 1 plus nx plus n minus 1 over 2 factorial, x plus x squared plus n minus 1 over 3 factorial, x cube here. This is n minus 1 and minus 2 over 3 factorial x cube, and so on. So I'm just straight away applying that formula. So if you simplify it, is 1 negative x, positive x squared, negative x cubed, because the other things get cancelled. So this is the expansion of the first bracket here. Now I'm going to expand the second bracket. So the second bracket is actually negative 2, that is negative 2 plus x to the power minus 1. So I'm just going to expand this part first now. So I'm not going to talk about this negative 2 here. So you're going to take negative 2 common. So if I take negative 2 common, this power belongs to minus 1 belongs to both, and it becomes 1 minus x over 2 to the power minus 1. So this is going to become eventually negative half and 1 minus x over 2 to the power minus 1. So now the expansion of this part is, let's take 1, negative 1 half as it is, don't touch it. And you got 1 plus n. N is negative 1. So negative 1 times x is actually negative x by 2 plus n, which is negative 1, negative 2, negative x by 2 the whole square, and this is 2 factorial. And the third one is negative 1, negative 1, negative 2, negative 3 over 3 factorial, negative x over 2 the whole cube. So this is up till x cube I wanted. So I'm just going to simplify this, I'm just going to rewrite the same thing here. So what I got is negative half outside, and we got, if I simplify this, it is 1 plus x over 2, and this is positive, this get cancelled, and it is x squared over 4, and this get cancelled with negative, so there are, this get cancelled overall, and there is a minus that comes out, so it is x cubed over 8, and so on. So now I'm going to make use of the expansion which I did here. So first bracket that I got was 3 times this expansion, which is 1 minus x plus x squared minus x cubed, and plus negative 2 times negative half out here, and then this entire bracket. So 1 plus x over 2 plus x squared over 4 plus x cubed over 8. Now this and this get cancelled, so actually it is now 3 minus 3x plus 3x squared minus 3x cubed, and my second bracket is positive 1 plus x over 2 plus x squared over 4 plus x cubed over 8. Now you're going to add up the like terms, so I'm going to just clear these out. I'm just going to add up the like terms. So my like terms are 3 goes with 1, that comes to 4. Negative 3x comes with x over 2, so this is negative 5 over 2x. Then I've got 3 plus 1/4, so it is 13 over 4x squared, and it is negative 3 plus 1/8, so that is negative 23 over 8x cubed. So this is how you write down the expansion. Let's just quickly check the answers that we got, whether it is right or wrong. So the actual answer that you can see are here. So 4, negative 5 over 2x, 13 over 4x squared, and negative 23 over 8x cubed. Now this is not over yet here. This is not over yet. So I'm just going to go back to the question. And now the next part that they ask us is, for what x values does the series converge? Now, we wrote the expansion of 3x plus 1 raised to minus 1 and negative 2, negative 2 plus x to the power minus 1. Now, as you can see that there are two expansions, series expansions. Now, the first series converge for x between minus 1 and 1. And the second one, if I took that thing common, it was actually plus here, plus 1, and it became 1 minus x over 2 to the power minus 1, as I simplified earlier. Now this part, negative x by 2, absolute value, that is x over 2, should be less than 1. That gives us x is between minus 2 and 2. Now, if you look at both the series, they are something like this. This first one converged from minus 1 to 1, and second one converged from minus 2 to 2. So when you look at the common part of conversions, that is, this part is here, and this part is, the red part is here. This the intersection is only between minus 1 and 1. So they both will converge for x between minus 1 and 1. So that's my answer for convergence. So if there are 3 terms, let's say there are 3 series like this, this, and some more, you're going to look at where does the third series converge. And if that is, let's say, for example, is between this to this, between minus half to half, then all 3 of them will be converging between that point only. So you always look at the intersection of the domains. The last one is pretty easy, actually, when you look at, now you have to just find out x is 0.05. So you plug x is 0.05 here and make the calculations. So this is how you do the series with the negative indices and partial fraction.